So another way you can think about this, if you have your molecule and you can see a mirror image, or a plane of symmetry, sorry, you know that its enantiomer is going to be meso to it. Whereas if you make it a diastereomer, then you just have to flip one of them. So there are two. So notice this guy here, there isn't a mirror image. So I know that his mirror image is an enantiomer.
Really?
And then these guys, the diagonal is also, they're also diastereomers to each other.
Mm-hmm.
And then if I drew this guy's mirror image, clearly these two are meso to each other. They're the exact same thing. So a lot of questions will ask you how many potential isomers are there. And that's where we use 2 to the n.
Mm-hmm.
And when we use that formula, the n equals what? Number of
chirality centers, or I guess anything that creates stereo
chirality. Yeah.
So it is
Centers.
today.
And then, but what happens if we have a plane of symmetry?
Then
N minus number, really it's n minus number of plane of symmetries.
Oh,
Oh wait. I don't want to do that.
we haven't got that far yet.
exciting.
I know.
Actually, so it's 2 to the n minus, so you don't, it's not n, minus
the whole thing.
number of plane of symmetries. So if you think on this one, if I gave you this molecule, actually let me do a different one. And its number of possible plane symmetries. So let's look at this one here. And if I ask you how many chirality, how many isomers are there of this molecule?
Okay.
So we first asked ourselves, how many chiral carbons are there?
I would suspect 4.
Yep, there are 4, so we're going to go 2 to the 4th. Okay. How many plane of symmetries can there be?
I can see each one.
We have 1 here,
Is that one right there?
we have 1 here, we have 1 here, and we have 1 here.
How is that plane symmetry if one's going back?
Well, it's potential plane of symmetries. So in this case, there
Oh.
isn't, but I could
If
flip
you
this
brought
to
that
make
forward.
one. So in this case, you gotta look at potential plane of symmetries.
Well, that's crazy.
So by flipping it, you're not flipping the entire ring, you're just flipping that one
Yeah, I'm gonna move it forward.
thing. It's like the helicopter thing, you just spin the blades. Run it towards you.
So
That's
we have what? We said there's 1, 2, 3, right? So 2 to the 4th is,
16.
so that means we know there's gonna be, should be 13 different.
Wow. Possible. And plane symmetry is it has to be the exact same on both sides.
Yeah. So this molecule might be chiral because there is no plane of symmetry, but if we're thinking all potential stereoisomers, we gotta think of it as if they, how could you change it so there could be a plane of symmetry?
Cool.
That make, it's just like on this example, maybe I'll do an easier one. Let's say I give you this molecule, And then I asked you how many diastereomers or isomers are there of this?
Mm-hmm.
There'd be
Yeah,
2, 4,
So
4.
2 to the second,
right, so that'd be 4. Minus number of possible.
and there's how many possible plane symmetries here?
I see 1.
Yeah, 1, so that's 3. And if you remember, when we did this one, we said, okay, this guy's mirror image looks like this. So those are enantiomers to each other, and then a diastereomer to it was this guy. But his mirror image was the same thing as this, so there's only 3 potential.
Mm.
So even though the one I gave you doesn't have a plane of symmetry,
Mm-hmm.
you gotta look at it and think, okay, it could possibly have a plane of
One
symmetry.
of the answers. Oh, yeah, that makes sense, because if there's a plane of symmetry, then its mirror image will be the same, so you don't count it.
So your image of that would have the 2 dashes and 2 wedges.
2 dashes are the same thing as the 2 wedges, you just have to pancake it. Or if you pancake this guy, these two are obviously different.
Different. Okay. Oh, that's how you look at it. Okay.
Does that make sense with the whole meso deal?
Yeah,
think
that
so.
makes a lot of sense.
What does the word racemic mean then?
Racemic.
Oh, I do notice I wrote it down. That's when.
Oh,
Oh, that's the combination 50-50
mixture
Yeah.
of S and R.
So is it chiral or achiral?
Well, the individual pieces are chiral, but their combination is achiral.
Yep.